What are these RC models? The step response. What is the difference between the step response of a lumped model and a distributed RC network? For example, if you look at propagation delay from 0 to 50%, a lumped network would use a delay of 0.69 of RC, whereas in a real RC network, the delay would be only 0.38 RC. And the 10% to 90% delay would be much larger, much pessimistic for a lumped network than for a distributed network. So what does it mean? It means that lumped nahi use karna hai. Instead, we would want to use something like a pi model. So you see, this looks like a pi or like a T model. Okay. And what has been empirically observed is that a 3-stage pi model, a pi 3 model or a T3 model is a very accurate representation of most of the designs. Okay. Now, typically you will see that when you do not really want absolute picosecond level accuracy, you can as well go to a single pi model. But if you really want very high accuracy, a pi 3 model is still good enough. And there's much lesser simulation time than a real distributed RC network.
Sir, why
Yes.
is it lesser simulation time, sir?
You tell me.
Yes, sir.
How do simulators work?
Yeah, I'm not sure, sir.
So you studied matrices in your mathematics courses?
Yes, sir.
All of you have. Even BTech students at Triple IIT and MTech students have studied matrices. Am I right?
Yes, sir.
So you thought they were being taught for esoteric purpose? No, they were taught because those are actually used by simulators. So simulators make matrices, and for every device they have a row or a column associated with them, and that is how simulators do matrix transformations, do their calculations, and so on. Okay? Because there are multiple things which are working together. So all those parallel threads or all those parallel nodes are evaluated simultaneously. So if you have more number of elements, what happens? The matrix size increases.
Sir, actually matrix size depends on number of nodes, sir. So yeah, I think I could relate with that. Like there are number of nodes are increasing. So yes.
So as soon as you increase the total number of elements, things would increase. The simulation time increases. Okay.
Sir, actually you said simulation time would decrease, sir. And like that's the reason why
simulation time would decrease with a pi model, and a pi 3 would it would decrease from a distributed RC network. A distributed RC network would have thousands of small resistances and capacitances that would have in it.
Okay, yes, sir.
We are lumping them into a pi model or a pi 3 model. So from there, the simulation time would definitely reduce significantly. Okay.
So the simulation time is more in pi 3 model, right, sir?
Than pi model.
Yes, sir. Okay.
But it is still much lesser than a distributed network.
Okay, sir.
Okay. Meher?
Yeah, sir. I am not familiar with the term distributed RC network. So what's the difference?
So distributed RC network. We just showed that in the previous slide. Huh? This is the distributed. So over here, this is just distributed C, but there is a long wire, and we say that okay, all these small resistances, I will actually show all the small resistances. I will not lump them.
Okay.
That is distributed RC. So what you say is that okay, I had this wire going from here to the inverter, and then it took a turn, it went into a NOR gate or something, huh? So it would a distributed RC network would say, okay, I would want to make a RC of this. I would want to make a RC of this. I would want to make a RC of this, a separate RC of this, RC of this, RC of this, and so on. ठीक है और ये तो मैंने अभी schematic view दिखाया है. As soon as I make the layout view, you will see the metal would have moved from VR1 to VR2, from metal 1 to metal 2 through a VR1. So all those transitions, you will see. Okay, so आप जब post out extraction करेंगे, So the first extracted file, you will see there are so many resistances and so many capacitances because at every VI it is taking a break.
Yeah. Yeah.
Okay, every VI it says, no, now the new wire has started. So I will model it separately. So a new capacitance comes into picture, a new resistance comes into picture. Every turn something happens. Okay, so that is distributed RC. And you can imagine how many resistance. So आप एक simple inverter ही बना रहे होंगे तो उसके अंदर कितने सारे RC आ जाएंगे just because of metal one. You realize this?
Yeah.
Yeah.
So how did we? So like I understand how for in a distributed RC network you will have that specific delay of 0.38. Right? Yeah. So but how did we arrive for this for lumped RC network 0.69 RC? It was,
Yeah,
did we compute-
we simply calculated, analyzed.
Okay, so it's a
So
common characteristic for all
RC,
the
yeah, मतलब
lumped RC.
आप एक distributed RC network बनाओ और उसको analyze करो, you will see that 0 to 50% propagation delay would be something which will be 0.38 RC, and if you just make a lumped thing, and you will see that the delay would be different. That's it. We just did the analysis. जो circuit theory वाला course.
Okay, so
CTD में you must have done RC networks, na?
yeah, yes.
Yeah, that's it. Same
So
thing.
does lumped RC network modeling with lumped RC network offers a certain advantage? Because if distributed RC network has, if we are trying to convert it into a distributed RC network.
Yeah, यही तो भी बात कर रहे थे ना मेहर, that the simulation time would reduce if I have lesser components.
I understand.
That was what we were just talking about. That is why we're talking about these models. Otherwise, the distributed was good enough. It was very accurate.
Okay. Okay.
Raghav?
Yes, sir. So this pi model and distributed RC are different things, two different things.
Yeah. Distributed RC, जैसे मैंने अभी बताया, every turn, every via, it assumes it to be a separate wire, and it will make an RC for it.
So even for the via,
yeah, because via has a different resistance model for it. So if you will open the DRM of any technology, you will see that resistances and vias, capacitance, contacts and vias have a completely different resistance profile than wires.
So, but they are also copper, right? So why is different?
They are. समझते नहीं हैं लोग. So the thing is that see, via के through जो current flow होना है, that length is not in your control, is it?
No, sir. Yeah.
See, when I make a wire, I can decide how long or short I have to make this wire. But for a via, you have no control over this depth. This is defined by the process.
Yes, sir.
So whenever we put a via, we say this via has a resistance of 10 ohms, let us say. Now, if I cannot afford 10 ohms, I will put 2 vias. What will be the effective resistance?
5.
I make 3 vias, 4 vias, and I can reduce the overall resistance. Okay. So see, in a wire, you can reduce the resistance by making wider wires.
Yes, sir.
But vias, you can't do that. Therefore, vias का resistance अलग से दिया जाता है. And therefore, because it is given separately, the tool understands it as a separate wire.
So, sir, in the Elmore delay slide, that was basically a distributed network you were showing.
That was
this one.
Yeah. So you can call it a distributed network. You may not. In the sense that because I have not really shown all the different, or I have not shown these 3 components separately to you, have I? I have lumped all of this into one RC. Hai na?
Yes, sir.
So this is not really a distributed, not purely distributed. But yeah, wherever there is a turn, even a pi model, you will have to model it like this then.
Okay. So, but like, what is the difference between the lumped and the distributed one? The lumped was actually, I'm not getting confused between that.
Oh, lumped. Lumped में तो कुछ भी नहीं था. Lumped. This is lumped.
Okay. In lumped, we have no resistance also. Model.
No resistance, and all the capacitance are simply added.
Okay. In distributed, we are considering all the resistance separately and all the capacitance separately.
In distributed, yes.
And
And then we come to an intermediate pi or a T model.
so like pi is like an intermediate between the lumped and the distributed, you can say.
Yes.
Okay. Yeah, sir. Got it, sir. Thanks.
Because we do not pay that much simulation time, but we get almost similar accuracy.
Yes, sir. Got it, sir.
Okay. So while 3-segment pi model, as I mentioned, is very accurate, but typically single segment pi model is used. Okay. So now we come to crosstalk. You understand what crosstalk is? You've heard about this term earlier?
Yes, sir.
Raghav?
Yes.
Yeah, Raghav, you have a question? I see your hand raised.
Yes, sir. Sorry to forget, sir.
Faisal?
So I have the question from the VR part that you were saying, like if we want lesser resistance, we can add 2 or 3 VRs. But I have read in the course like the cost of fabricating a VR is much more than the metals. So is it feasible to have 2 or 3 VRs in place of one to just reduce the resistance, or is it a good thing like?
So if it is not leading to any increase in area,
Okay. Yes,
we would
sir.
usually want to have redundancy in VRs and contacts.
Okay.
Okay. But if you do not want to go for an overkill either, for example, if you make a P cell of a device which is, let us say, 10 micron wide, you will see there are hundreds of contacts it will put automatically. देखा है आपने?
नहीं sir.
You need not use a P cell at all for making your inverter layout.
नहीं, I've used, yeah.
So when you made the P cell and you made a device of, let us say, 4 micron width, how many contacts did it put on the source and drain?
That you have told in the
Tens
class.
of them.
Yeah.
No, as many as it could put.
Yes, sir.
So that is an overkill. So that leads to increase in gate capacitance, gate to source and gate to drain capacitance.
Yes, sir.
That
Yes,
we don't want to do. But we definitely would want to say that, okay, every third contact I would want to keep, or every second contact I would want to keep.
Yes, sir.
So that I reduce the total capacitance between gate and these contacts, poly and contacts, but I am able to reduce the resistance also.
Okay.
Okay. So multiple or this redundancy of resistances and VRs is preferred. This is in fact called as design for manufacturability, DFM.
Okay.
So there are checks. There are checks which say that you could have put 2 contacts over here. Why did you put only 1?
Okay.
So there are such checks also, but we have to be very judicious. We have to be very careful कि हम overdo ना कर दें.
Okay, sir. Yes, sir.
Madhur?
Yeah, so in this pi or T model, when we have very long wires, then this may be true. But when we have wires which branch too much, then maybe this model will fail because there are parallel.
So actually, it is for global signals that we use these pi and T models. Small interconnects, the resistances and capacitances are small enough. So उधर कुछ भी हो कोई फर्क नहीं पड़ता. See, if the overall value of the delay is 10 picoseconds, whether you're measuring it accurately at 9.7 picoseconds or whether you're measuring it at 8 picoseconds, 2 picoseconds तो आपके simulator की inaccuracy है. Doesn't matter. So if the delays that could be impacted are within the accuracy of your simulator or your simulation setup, you don't bother about making pi and T models. Only when you have global signals where the interconnect delay, जैसे हमने पहले बात करी, that interconnect delay could be 30% to 70% of your critical path delay. So for the big delays, you want to model them as pi or T.
Okay, sir. So we need accuracy when we are dealing with such long interconnects.
Yes, when we're dealing with long interconnects, we definitely need accuracy, some accuracy.
Okay, sir.
Lumped से देखो ना, lumped versus distributed में कितना बड़ा फर्क था otherwise.
Yes, sir.
We can't afford that. Gagandeep?
Yes, sir. Sir, I was asking that if you give me a circuit and say that, okay, this much amount of delay I have to meet. So as a designer, when I'm starting to look at all the topologies that I can use, so how can I really use this kind of model, because I do not know the length or
वायर्स के लिए आप कुछ नहीं कर सकते गगनदीप at the time of schematic design. So what you can do is, okay, this capacitance is of very high importance to me. This delay is the longest delay, so I would not want to add any wire delay into it. So you say you can put comments in your schematic that make the layout of these devices as close to each other as possible, so that when you start to lay them out, you remember, okay, this was an important consideration. So that you can do when making the layout. But otherwise, you cannot really do much. So what we usually do is we simply add some parasitic capacitance on every intermediate node. We say, okay, this node is going from one inverter to another, at least two femtofarad capacitance to aa jayega. So we just put some value there, so that our final delays are not far away from our initial targets.
based upon experience?
Yeah, based on experience and technology characterization and stuff like that. Yes. Meher?
Yeah, so just to clarify, the difference between lumped and distributed is for every turn of the wire, we will associate it with a resistance and a capacitance. But what lumped does is it models the same between two nodes. So that diagram you were showing, it was taking all those turns and curves and modeling it as one resistance and one capacitance.
Yes,
That's the
that's lump.
okay. And sir, another thing you mentioned a point about the number of contacts we had when we were modeling for a certain width of PMOS or NMOS, and how we should be careful not to do an overkill, right? So when we reduce the number of contacts, I understand how that would reduce the capacitance between the poly and the contact, but how will that affect the resistance exactly? I didn't get it.
So see, contact resistance, let us say, is 10 ohms, let us say.
Okay.
And you made 10 contacts.
Yeah.
So resistance became 1 ohm. Now you reduce 5 of them. 1 की जगह 2 हो गया.
Okay.
But 1 is like 2 is as low as 1. उससे ज़्यादा आपका ड्राइवर का रेजिस्टेंस है ना?
Yes, sir.
So you say, okay, let me have 2, or let me have lesser contacts than all 10 of them.
That's not really a trade-off in the sense that the resistance doesn't have that much impact in terms of magnitude.
Yeah, because finally, if it is a very big driver, then the resistance of the global RC network is more important.
Okay.
Then there will be other constraints which could come because of the total current that this RC network has to drive. For example, if it's a very huge capacitance and you're talking of driving it every clock cycle, then you understand that, okay,
Yeah,
if a current has to flow in every cycle, then I have to be careful that even after some aging and some degradation in resistances, even after that, my system will work fine. So then you may want to put 7 contacts instead of 5. So there are rules for that also. There are rules linked to electromigration also. So don't worry. These are slightly advanced topics. We will possibly talk about these failure modes in the last lecture of this course.
Okay, sir.
Okay.
But in the last point you mentioned that in that case, if we are talking about huge driver of current, then we will increase number of contacts.
So 10. So let us assume that 10 were the by default you got from P cell. That is the maximum contacts you can put.
Yeah.
We said we will, in a typical case, when it is not a very big driver, we will reduce from 10 to 5 or 10 to 4.
Okay.
But if this driver is operating every cycle, if the activity rate of this driver is very high, then electromigration rules may require me to put 7 contacts instead of 4 or 5.
Okay.
So that even after aging, things are fine.